Hi class, welcome to today's at-home preview lesson called Periodic Behavior. During this lesson, we will be looking at the four main trends of the periodic table of elements, and I will be giving you a few tips on the best way to distinguish between them. Up until this point, we have discussed a few topics regarding the periodic table that you should be familiar with, but in case you need a refresher, let's go back and touch on them a little bit. First, the periodic table has 7 rows called periods that are arranged from left to right, and each of the elements that are in a specific period all have the same number of atomic orbitals. The periodic table also has 18 columns that we call groups, and each of the elements in a specific group have the same number of valence electrons. Secondly, the periodic table is broken up according to families, which are grouped by their chemical properties. There are the halogens, which is group 17, noble gases, which is group 18, and metals, which make up almost 75% of all of the elements. These metals consist of alkali metals, alkali earth metals, transition metals, lanthanide series metals that are rare earth metals, and the actinide series metals that are all radioactive. Lastly, the first 18 elements on the periodic table make up most of the matter in the universe. Just a quick little fun fact. So now it's time to get to know the four main periodic table trends, and they are atomic radius, ionization energy, electronegativity, and ionic radius. The first one, the atomic radius, can be considered the traveler, as it is the distance from the nucleus to the outermost energy layer where the valence electrons are located. Each row adds a new energy level to the atom, which creates a further distance, and the more protons you add to the nucleus, the closer they will pull the electrons towards the nucleus. Therefore, the atomic radius increases down a column and decreases across a row from left to right. The second trend, ionization energy, can be referred to as the mover. It is the energy required to remove an electron from an atom, and this depends entirely on what we call shielding, a concept that explains how the inner orbital electrons block the protons in the nucleus from seeing the valence electrons in the outermost shell. Ionization energy has an inverse relationship with atomic radius, as energy decreases down a column and increases across a row. Therefore, helium has the largest ionization energy as it requires the most energy to remove one electron from its outer shell. The third trend, electronegativity, is a combination of both atomic radius and ionization trends. It can be viewed as a relationship of the taker versus the giver. More specifically, it is a measurement of an atom's attraction for another atom's electrons. Let's just keep in mind that all elements, and I do mean all, want to be just like noble gases. Noble gases have a full outer shell of 8 valence electrons, which is considered to be a complete octet. Nonmetals have a high electronegativity, as they want to take another atom's electrons, while transition metals want to give another atom their electrons, and they do so willingly. When looking at the column trend of electronegativity, think the smaller the stronger. Hence, hydrogen will have a higher electronegativity than francium. Noble gases have a complete octet of 8, so their electronegativity would be 0, as they don't want to give or take any other atom's electrons. Therefore, fluorine is the most electronegative, as it has the highest desire to take another atom's electrons. Lastly, let's look at the final main periodic table trend, ionic radius, or what I like to consider the fluctuating relationship of losing weight and gaining weight. Ions are atoms that have lost or gained electrons. In other words, they are no longer neutral and have a charge. There are two kinds of ions, cations, which are positive, and anions, which are negative. When thinking about remembering the two, think cations, underline cat, are positive, and anions are a negative ion, A, N, and ion all being underlined. Metals are cations and nonmetals are anions. Metals who willingly give away their electrons lose weight and become smaller as they lose their electrons. Nonmetals who want to take another atom's electrons gain weight and become larger as they gain electrons. This is all in comparison to its size at its neutral state. So as a wrap up, in today's lesson, you learned about the four main periodic table trends and the easiest ways to depict between them. For homework, create a narrative PowerPoint of your own with 5 slides max on your assigned element discussing its properties and its relation to the trends. Your assigned element was given to you during our last class period. Tomorrow, in class, we will discuss these trends more in depth and you will present your individual presentations. See you then.